In this video, I will show how to solve a half-life problem. So let's read the question. We have plutonium whose half-life is given, and the question is, given 10 grams of plutonium, how long will it take to decay to 1 gram? First step is to recognize that plutonium decays exponentially and continuously. Therefore, the amount of plutonium that you have at time t can be written using this formula. Where A0 is the initial amount and R is the continuous decay rate. So if we were to know both A0 and R, then the question is very simple. It's just basically we just have to solve the following equation. Set A of t equals to 1 and then find the value of t which makes this true, and that value of t answers the question. However, from the problem, the way it's given, we can only assume that A0 is 10 by setting the t equal to 0 equal to the current moment. So if we set t equals to 0 for now, then the initial value is 10 grams. So the only thing we have to find now in order to start using the model is R. And to find R, this is where we have to use that statement about the half-life. So how do we interpret that the half-life of plutonium-239 is 24,400 years? That means that if we were to leave the plutonium, the 10 grams of plutonium for 24,400 years, then in 24,400 years, we'll have exactly half of it left. So the function evaluated at 24,400 is equal to 5, assuming that the initial amount was 10. So what does that mean? That means if I plug in 24,400 into the function, I'll get 5. But this is a simple exponential equation for R, so I can easily solve it by isolating first exponential expression, then taking natural logarithm of both sides, and then dividing both sides by 24,400. So this I can compute using a calculator. So I'm just going to take a ln of 1/2 and divide it by 24,400. So the answer is -0.00. There are 4 zeros, and then there's 284. So this is what we just found is the continuous decay rate in the model that we are trying to use. So now we have everything. So we have choose t to be such that A0 is 10, and we just found R using the half-life statement. So the formula is 10 times e to the power negative 0.000284 t. And now using this formula, all I have to do is just solve this equation. So A of t equals to 1 means 10 times e to the negative 0.000284 t is equal to 1. And I can solve this equation for t. I can take natural log of both sides. And then I can divide both sides by this coefficient on the left. So the answer is which is roughly 81,000 years and 55